Could you have created a graph for this problem on your own? Very much so. Is that a valid strategy? Yes. Now you don't have to, but you can do that. We'll talk through it. But as soon as I see linear function, I'm thinking equation of a line. I'm going to write this equation out. I'm going to do this because that's going to help me focus my attention. Because what should we know from that equation right away? That is slope-intercept form, so what do I need to calculate though? The slope. Anyone remember an equation we've already written? Okay, rise divided by run, but usually what representation do we have for rise divided by run? No, listen. Yes, I'm going to get to that in a second, but listen to my question. What representation do we usually use rise divided by run for? Yes, but which mathematical representation? An equation, a graph, a table, a picture. If we're talking about rise divided by run, we're usually talking about a graph. Do I have a graph? No. What's the other option that I heard a couple of us talking about? Change in y divided by change in, not run, x. Remember, the rise is my change in the y values. The run is the change in the x values. It's the horizontal part, right? Can you find how much the y and the x are changing by each time in that table? Yes. Yes. And then now I will also need b. What is b? Well, it's that y value of the y-intercept. See if you can find that y value of the y-intercept in that table. But I'm going to point out, I am writing stuff down on the board. You will have to justify your answers on assessments. So every single one of us should have something else to write on to try to tackle this problem. Practice good habits of justifying your answers. Let's get some paper out. Let's work this out. We're going to get started in just a couple of minutes. What are you doing? You're what?
Again, you stress it.
Yeah, there's paper towels right back there. They're right next to the camera. How's that work going, Jordan? Are you logged in? Oh, you want to log in? Come on. Let's get to work. Ethan, how's that work going? Wake up. Stand up and walk around if you need to, but you need to be actively working. Come on. Tomorrow. That's not an equation of a line, my man.
I know I had something.
Okay, well, let's get out a sheet of paper and let's start writing, because you can't do it without writing something down. Joe, you're trying to type stuff out without writing out. No, sir, Joe. No, stop it. You have not written a single thing out. How are you going to answer the equation of a line if you haven't shown a single lick of work? Oh, Mr. King, I'm going to get frustrated with you because I don't know how to do this, but I'm not going to do what you're asking me to do. That doesn't make any sense, dude. I'm telling you. That's not true. But if I'm directly telling you, do this thing, and then you don't do it, and then you get frustrated that you don't understand, that doesn't make sense. I told you to write down that equation. I told you what different parts of that equation mean.
What equation?
Joey, there's two equations on the board, man. There's only two.
Which equation do you want to write?
Talk to you agree with that. I told y'all.
Do you remember what slope and it's the first equation right there? So that would be
That's the one that's cracked, right? I gotta replace
You're
it.
just looking for slope. So that means you don't need anything for the y, so you trace a lot. And then go to the equation and then find it. So now you're looking for area of slope. So what is negative 2? Like how do you get from negative 2 to 0? Yeah, so that's our the rise over rise. So how many does it say? 5 to 8. So since that's our rise, we're going to start at 3. Divide it up. You said go up 2. So it'd be 3 halves. And then you need a plus. I'm not think that this is just That's what I would have done.
Hey Wesley, did you get your equations in, Russ? Guys, we only have 10 equations in. We gotta get going. We'll go over it. Don't sweat it too much. Why, what's the equals? You can leave it like that.
Y-intercept is everything that's unlocked in the business.
That's fine. I just needed you to try. Joey, you still haven't gotten a single sheet of paper out to take any notes as we go over this. Joey, I can't help you if you're not trying. And if you're not doing what I'm asking you to do, you can say that you're trying, but you're not trying if you're not doing what I'm asking you to do.
I don't know what you want me to do.
Well, there's this weird thing where I said get out a sheet of paper and show your work, and you haven't even done a sheet of paper. I've given you, and we've talked about the equation of a line multiple times in class up to this point. Where are your notes on that? No, I just said it from my mind. Come on. If I'm teaching you and I'm expecting you to know it, then yes, you're supposed to take notes on it. Well, then you better pay attention. You take anything I write down on the board, you write it down. I can't help you if you're not taking notes, man. Get a sheet of paper. Jordan, make sure you're ready to write down something on that paper. All right, we're going to get started going over this. Guys, I cannot emphasize this enough. That if I say, hey, do this thing because it's going to help you, and then you sit there and you don't do that thing, you're not going to learn well. Like, hey, take notes on the equation of a line and slope formula and stuff like that. And you don't take notes on it. Miss Estel was here last Monday and spent an entire day with y'all on slope-intercept form of a line and how to calculate slope. An entire day. The only other, the sub who was here on Monday who taught while I was absent. Okay, we got to take notes on these things. I'm going to pause this because I'm looking here and I only see, I think, 3 students who fully got this answer right. Which means we got some things that we got to pay attention to. We're going to go over it. Alright, so let's look at this. We've already talked about it. If you are asked for the equation of a line, what should you immediately write down, Jordan? If I ask you for the equation of a line, what should you immediately write down?
Slope.
Well, you may need slope eventually, but if I ask you for the equation of a line, what do you need to write down, Emily?
The slope-intercept form.
You need to write down slope-intercept form. There are other forms of equations of lines, but you won't study those until you get into Algebra 1. This is the slope-intercept form of a line. So if I ask you for an equation of a line, bam, there it is. Joey, what are you going to write down if I ask you for the equation of a line? You got that? You have it written down? Okay, you can ignore me. But I don't want to hear frustration when you don't remember what the equation of a line is.
I remember what the equation of one is. I remember it from last year. Oh, look, let me write that down.
But Joey, you didn't remember that when the question was first asked of you. I'm just saying.
I can't read mine.
Hey Joey, there's no need to read a mind. It says write an equation for the linear function. Write the equation of a line.
Just with that information, I can't tell what equation I'm supposed to write.
But Joey, that's my point. If it asks, and you should write that down, if it asks for the equation of a linear function or the equation of a line, you need to write that equation down. So it would be a good note for you if you didn't recognize that to say, when Mr. Kinney asked for the equation of a linear function, that's the equation he's asking for. So that is the slope-intercept form of a line. Actually, let me pause and point this out, and I need y'all to remember this. What is math as a whole? Like, what is mathematics? Study of patterns and relationships, right? And so, in a way, mathematics is also starts with an L. Language. I need y'all to very clearly understand, I'm not asking you to read my mind. I'm telling you that the proper language for this is the equation of a linear function. If that is ever asked for in my class, on the ACT, on any other test that you ever take, that's what they're asking for, the equation for a linear function, the equation of a line. Okay? That is the proper mathematical language for this. So we want the slope-intercept form of a line. And so slope is rise divided by run, or the change in y divided by change in x. But we need to be careful, because only a handful of us got this part right. Was it negative 2, 5, 0, 8, 2, 11, 4, 14? Is that where it ended, or one more? 6 and 17? Is that right?
Yes.
Okay. And so, is the change in y on the right-hand side or on the left-hand side?
On right.
Y'all need to pay attention. The change in y is over here. A lot of us miss this. The change in y is 3. What's the change in x then?
2.
That's 2. So 3 divided by 2 should have been what we wrote here for m. We need to be careful about that. A lot of students just look at this part first and then put this part. But that's not right, because I need the change in y divided by the change in x. So 3 halves, or 3 divided by 2x. Now I need, what's that b again?
Y-intercept.
The y-intercept. And I saw some 5s in there. I saw that 3, which I will guess that the 3 is coming from here, but no, the 3 is the change in y. But I need the y-intercept. How do we identify the y-intercept? Okay, so I'm going to talk about another way to see it in a second. But if we understand the y-intercept is the point going through the y-axis, what would I need to draw? A graph. Because you've got a piece of graph paper and drawn out this line. Right? Looks like that's what Nathan did. So I'm going to just scale by 1s. Ezra, please focus. All right. So the first point I have is negative 2, 5. 1, 2, 3, 4, 5. Then I've got 0, 1, 2, 3, 4, 5, 6, 7, 8. And then I've got 2, 11. So you tell me, what's the y-intercept? 0, 8. Does anyone know what is true? So plus 8. What is true about x for every y-intercept that has ever existed? The x value is always 0 for the y-intercept. I could have seen the y-intercept right here. There's my value for b. Because I want you to remember, and Nathan already said this, the y-intercept is always where you intersect the y-axis. Here's a point on the y-axis, right? It's not my y-intercept, that's a point. That point's 0, 3. Here's another point. What's that point? 0, it's only up 1. What's this point?
0, negative 1.
Look at every point on the y-axis. Every point on the y-axis has an x value of 0. And so I would make this note if I were you. X is always 0 for the y-intercept. X is always 0 for the y-intercept. That's an easy way to identify that y-intercept. X is always 0 for the y-intercept. So I've got the way I calculate my slope up there, I've got my y-intercept, and there's my equation. Did you ask any question, Joey?
I'm so confused how you even got the A.
Joey, what's a y-intercept, my man?
No.
Okay, so you might want to take a note on this as well. The y-intercept is where the function intersects the y-axis. And so one thing to clarify, make sure that everyone's clear on, did I put that entire y-intercept into the equation, the entire 0, 8? No, it is, the b is only the y value, right? The b is only that y value. So you see how there's that 8?
I can't even see the ground.
Well, then maybe you need to sit up here, bud. I don't know what to tell you, like, the line is here intersecting the y-axis right there. If you need to sit up here when I'm giving direct instruction, do that, or sit to the side there, but it's intersecting, here's the y-axis, it's intersecting right there at 0, 8. Okay? Like, it's intersecting the y-axis there, right? Okay, that's where the y-intercept is. That's what y-intercept is. By definition, it's where the graph intersects the y-axis. Okay? And so you need the y value of that y-intercept. All right. From here, we're going to pick up with the idea of bivariate data, specifically the idea of scatter plots, right? And we're going to wrap up that squared up task that we've been working on just with a couple of minutes. So let me actually send that file back out to the calculators. Alright, so you should have all gotten that file back. I actually need to reopen it. Okay, so this is where we left off. Actually, that's not it. Oh, actually... Oh, this is what I want to talk about. Sorry. So this is the squared up task in your notebook. I need this out. Now you good? Focus.
I don't know what I did.
What did you just say?
I don't know what I did. What?
I don't know what you did either, my man.
What?
Stop. Stop.
I didn't do something.
I need your sheet out. Hey guys, I know we've already finished these handful of questions, but I'm going to recap a couple things. So we need our squared up task out. We need to talk through a couple of details here with the idea of the least squares regression line. Now, huh? I have no clue. I don't know. All right. So, least least squares regression line. The least squares regression line is found by minimizing the sum of the area of the squares. So what was that in reference to? We looked at this a little bit last week. Remember we looked at this? So what is that idea of the least sum of squares? Okay, so remember how we put a line in here and we moved the line around? And we found out that these squares, the sum of those squares, could have a minimum value, right? And so the best line is the line that minimizes those squares. That's what we talked about pretty heavily. Now, what I want to remind you of is, where is this idea of a square even coming from in the first place? Okay, so the distance from the line. So if I look at this point, and I look at the distance from the line, what is that little line right there called? Starts with an R as well. Residual. So remember, this line is called a regression line. The distance that a value is from the regression function is called a residual. Okay? And remember, because this point is above, actually look on the sheet, how do we calculate the value of a residual? It's the actual value minus the predicted value. Now, the actual value would be this point. The predicted value would be the, where would the predicted value come from? Trent, you awake back there, my man? Your eyes aren't even on the board. No, Trent, get your head up. It's hard to learn without your eyes on the board. The line, remember, is where our predicted value is going to come from. We're going to talk heavily about the predicted value today. So we have our actual value, we have our predicted value, and the residual is the distance between. Because this point is above the line, is that residual positive or negative?
Positive.
Positive. This residual is negative because that point is below the line. Now remember, we don't want positive and negative, so what did we do to all those residuals? We squared them. That's where this square is coming from the idea of squaring our residuals to make them positive, and we tried to minimize that sum of squares. Yes, Joey?
What do we do Thursday?
This is what we did on Thursday.
How then again I didn't know.
Huh?
Then again I didn't know because remember I wasn't here.
Okay. Who works on this? You should have, it's the same thing we were working on Thursday. Just making sure. Yeah, you were here on Wednesday when we did this. It's the same task. It's called squared up. Okay. So we have our sum of squares there, and we minimize those sum of squares. And then, so we talked about that. We'll work through these problems. And this is where we wrapped up. And this is the most important part out of that lesson. So first things first, we had an equation. I believe the least squares regression line was it 0.266x? And it said plus a negative, was it 434?
No, it was
454, thank you. But I will point this out. We don't very often do plus and negative. How could I rewrite that plus and negative? Just minus, right? So I'm just going to rewrite it as minus 454. I would traditionally do that. And so we talked about this on, this is where we ended on Thursday, to interpret the slope and the y-intercept. I'm going to go ahead and tell you, we're going to have an assessment probably at the end of class, a really short one, beginning of class on Wednesday, one of those two. And one of the things you're definitely going to have to do is interpret the slope and y-intercept. It's on there. I've already made it. So, when we talk about slope, where do I see the slope in that equation? It's the what? It's the slope, it's the m, but where do I see it in this equation?
0.068.
Right. Remember, it's my equals m times x plus b. So my m is 0.266. Now, we've talked about it already where we calculated the slope as the change in y divided by the change in x, but I don't have anything under this. This is where we wrapped up on Friday. It's understood to be divided by 1. So especially for those of y'all who are absent on Friday, you need to pay attention to this. Slope is always change in y divided by change in x. So when I have that 0.266, that's the numerator. It's understood to be divided by 1. Yes, Maddie?
What's that over the y?
Over the y? Oh, this little symbol right there. It's literally called a hat. And the reason why, I'm not going to test y'all on this. I'm going to always do it because it's mathematically or statistically correct. This little hat tells me that it's a predicted y. Remember how this was a prediction? So we use that hat to indicate that it's not the actual value of the point, but it's a predicted value. That's a fantastic question. Thank you for bringing that up. That's just something I'm used to. Can I get this real quick? Thank you. So, yeah, that predicted y is what we're talking about there. So, fantastic question. So there's my slope, but notice it's not just identify the slope. It says to what? Interpret. Joey, do you not have this sheet, bud? Huh?
I have it out.
Are you taking notes on this?
Third, taking notes.
I don't have that shit.
Joey, if I'm writing on the board and you have the sheet in your hand, yes, you're supposed to be taking notes.
I can't read mine.
So, hey Joey, I've told you this and I'll say it again. If I'm writing on the board, you should write it down. Unless I tell you not to, you should write it down. If I literally am telling you that this is going to be on an assessment, then you need to write it down. There's a second sheet that I think is what it goes with.
There's a second one.
Yes, Joey.
Yeah.
Up here, yes, sir. So, Joey, I would keep those together. They're the same lesson. So, interpret the slope and y-intercept. So we talked about this. We have to identify what those variables mean. If we looked at that graph, what was along the y-axis?
Oh, the life expectancy.
It was the life expectancy. Remember, I know it's been a little bit, but the y was the life expectancy. What was the x? The years, right? And so we were able to then interpret or explain what this means. And so don't forget, should we start with the independent variable or the dependent variable? Independent, right? Right, well it's the x, and remember the y literally depends on what the x is. So we need to talk about that x. So as the years, what?
Increase by 1.
Right, and we want to keep that in mind. I'm going to tell you, you're crushing that aspect of it because even my Algebra 2 students last year really struggled with that. So just recognizing is as the years increase by 1 is huge. How do we know that the years are increasing?
Because it's a positive.
Not only is it positive, remember it's the change in x. It's important to recognize that that 1 connects with the change in x because that means our x's are changing. It's not one single x value. If x was just 1, then it would be the year 1. Okay, so as the years increase by 1,
The U.S. life expectancy typically increases by 0.266.
Where I had it right now.
U.S. life expectancy, yeah, we're recapping what we ended on, bud.
I thought this was,
The U.S. life expectancy typically, now why again are we using the idea of typically? Because we're not sure. It's a prediction, right? It's not exact. So the U.S. life expectancy typically increases
By 0.266.
by 0.266 years. Okay? So that's how we interpret the slope in context. I'm going to get some more practice with that today. And then what's the y-intercept? I think that's where we ended yesterday,
Y equals MX plus B.
or Thursday. Remember, y equals mx plus b is the equation of a line. I'm just asking about the y-intercept. So we've already done the slope.
Negative 454.
Now the one thing to remember is that's not the entire y-intercept, because the y-intercept is a point.
0 is negative.
0, comma, negative 454. Remember, what is the x value always for the y-intercept? 0. And I need y'all to pay attention to this because this is important and this is where a lot of students get tripped up. Does this say change in x?
No.
No. Does it say change in y?
No.
No. So things are not increasing anymore. Here it is just the x. Well again, x was the years, right? So in what year?
Then 0 year.
So in the year 0, which, does anyone know what year that would actually be?
80.
Yeah, it'd be 0 AD. Good job. Because everything was like 1900, right? 1900, 1910, 1920. So that 0 would be 0 AD. What is the y?
Oh, wait.
Negative 454 what? Years, referring to the,
Change your y. I mean, no.
not,
Okay.
I was saying, sorry, it's not change anymore, right? It's just y, so it's the life expectancy. The US life expectancy,
What do you say?
say again,
Is it month?
this is still number 16.
Oh.
So the US life expectancy is predicted to be, what?
454 years left.
Well, not 454 left, it would just be negative 454 years.
That can't happen.
Exactly. Here's the thing. We're interpreting this in context, but does that always mean it makes sense? No. Remember, the years that we had were from 1900 to, was it
2004.
2004?
Yeah.
There's an issue. We went 1900 years before this, year 0. Can we go that far back in time? No. It's an idea called extrapolation. We're going to look more heavily at it, and I'm glad you picked that up so quickly, Joey. You're right. Negative 454 isn't possible. Someone can't live a negative number of years. And so this is the issue with going too far outside of the data set that we have. But that's still how we would interpret it. Even if that interpretation doesn't make sense, that's how we would interpret it. Okay? I won't give you ones that make 0 sense like that, but that's still how you would interpret it. Okay?
What are assessments in this class?
Huh?
What are assessments?
Assessments are tests, quizzes, understanding checks, things like that.
Oh, joy.
You know, what's a joy is when you have such a positive attitude on things. So, number 17. What do you predict the life expectancy of Americans in 2040 to be? How would we figure that out?
You just make an educated guess.
No, we don't want to make an educated guess. We literally have an equation that's going to predict for us. What is that?
We do?
Yep.
Okay.
No, not a table.
Y equals slope.
What's it?
My question is, what do we have that's going to help us make a prediction? Yeah, we have a graph, and we can go back to it. Okay, so let's look at that graph. What on that graph is helping us make a prediction? That line, right? That regression line? Do we have an equation for that regression line? Yeah? So I have an equation right here. And I'm told that I'm looking at year 2040. What could that 2040 be substituted in for? The x was years, right? It was the year that we were looking at?
Yeah.
Yeah? So could I substitute 2040 in for x? Yeah. So substitute in for the correct variable which the correct variable is which one? X, right? You have to keep in mind the context there, but you substitute in for the correct variable. Substitute in for the correct variable in which equation? What is that equation called? It is sloped in some form of a line, but remember this was a special line. Which line was this? The which one? Okay, remember this is the one that had the minimum sum of squares, so it was the, starts with an L, in the least squares regression. Man, if only we focus as much on our learning as we did on getting the final answer.
No, I'm trying to see, like, is this notes?
Yes! I'm literally pointing out what to do here. Substitute in for the correct variable in the least squares regression line. I will point out, that's a mouthful, right?
Yes.
Usually, we abbreviate that. Any guesses with what letters? LSRL. Least squares regression line. Okay, so you will always see me abbreviate. If you ever see LSRL, that is the least squares regression line. Okay? So you're going to substitute in for the correct variable, in this case x, in the least squares regression line. Because what is that least squares regression line doing? It is making, starts with a P, predictions. Remember, the least squares regression line is the best trend line to make predictions. So if you don't remember that detail, this is the best trend line to make predictions. Are there other trend lines? Yes. But this is the best one because it's minimizing what? It's minimizing the, not predictions, it's minimizing the squares. Remember, that's the whole point, is that it's going to minimize those squares. So it's going to give us the best prediction. Right, Jordan? Good job, buddy. I need y'all to understand, I really do want y'all to be successful, but I cannot help you if you're not going to engage in class.
I don't know how to be successful.
I've been trying to tell you, if you follow what I ask you to do, you'll be successful.
So is that how I don't fail?
To be successful means you're learning and growing. You learn and grow in my class, there's no way to fail. Alright, so what do you predict the life expectancy of Americans in 2040 to be? We already said it, we're going to substitute 2040 in for x, so y hat equals 0.266 times 2040 plus, or no, minus 454. There it is. That's it. Now, let's use a calculator and let's simplify that. What's your question, Joey? Joey, what's your confusion?
Everything.
Nah, dude, you can't say everything. Where did I lose you? Because you seemed to be fine when I was standing over there.
When you wrote down that equation looking thing.
Not the equation looking thing. Joey, what does it say right here? Substitute 2040 in for the correct variable, which is x, right? The years are our x.
Yeah.
Remember how this was my least squares regression line?
No.
Okay, well that's the least squares regression line we've been talking about this whole time. And so I substituted 2040 in for x, bud. You're not an idiot, bud.
My grades say otherwise.
Your grades don't define how intelligent you are.
In this class they do.
No, they don't.
This is the only class I'm failing and I still don't see why.
So, what is the answer? 88.64? So 88.64 years is the what? Life expectancy of Americans, right? So, does that does that value make sense? I mean, does it make sense that someone could live to, the average could be 88.6 years?
Yes.
Yes. No, does that make sense, whereas, did this y-intercept make sense? So I want you to notice, this only went about 40 years into the future. This went 1900 in the past. So can we go a little bit into the future, maybe? Yes. Can we go really far into the future? No. And so that's what you want to pay attention to, is that you can look close to the data set you have, but you cannot look super far outside of it. Okay? Alright. We're going to skip the last page and get back to the materials in the book. So the notes that you have in the book come from here. Nope. Not the book, sorry. Yes, by the way, volume 1 of the book, the geometry book, the blue one that I gave you at the beginning of school, you will want that on Wednesday.
What?
What do you mean, what?
Oh, I know.
Yeah, I gave it to you, okay? So, this, listen, the book that we use, they have data analysis with Algebra 1 and geometry they have with probability. So, the stuff I've been printing out has come from the Algebra 1 book because we teach it in geometry, not in Algebra 1. But we're getting to the geometry side of things on Wednesday. So, I need us to look right here. We've already talked about this problem, right? We looked through, this was the temperature and the number of customers at the beginning. Did y'all know how to use the calculators originally to get a least squares regression line?
No.
No. Now you do. Okay?
You do.
Yes, Joey.
I know.
Okay, then we'll work within your small group to figure it out. Joey, please stop, man. I'm literally telling you that we're going to figure it out.
What's the point of it?
So
I'm always going to be the idiotic one in this whole freaking group.
that's not true, my man.
No matter what group I'm in, I'm always going to be the dumb one.
Joey, you're not helping yourself grow or learn. If you need to step outside, step outside. Calm yourself down. Say again, sir?
This one.
Yes. I think it's M1-170. It would be, yeah, this page right here, that's numbers 4 and 5. Okay.
I'm sorry. My sympathy is good.
I had a stripper.
We get it. That's a nice iPad. We don't care.
I've been out there a while. It's like, go dead and never told and then he won't even answer.
Yeah, but we're big. Yeah, see, it only catches his head.
I want to make a big.
I'm telling you, man. Anytime my girl walks around, pass them down, send them to vote for.
about Trent. Trent, how I call you.
Excuse me. Conversation stop. Y'all need to chill and sit there in your desk.
Yes, sir.
I stole one of the trips where get so sewer down.
You need to reach that.
Where did that come from?
So, we already looked at these data points. We graphed it out by hand earlier in this lesson. We also drew a trend line for number 1, I believe. Or we wrote an equation for a trend line for number 1. Now we're going to look at the least squares regression line. And so it says use the data table and a graphing calculator to generate a line of best fit. So what kind of page do you need to create to get started on this? You have to do a spreadsheet so that you can enter this data. So what I would do if I were you, hey listen, because you no longer need this, I would hit the home button so that you see this page, and I would create a new document. Okay? Do not worry about saving changes. Right? So hit home, create a new document, do not save changes. And what page do we need?
A spreadsheet.
List of spreadsheets. And so I would enter my X values, my Y values. Now what are the names for those variables? Temp and customers. Alright, so I would type out just temp, that's easy enough. And then customers. Alright, so enter your values in there, and let's use our data and statistics page. It's on page 170, thank you. The table is actually on page 168, yep. So the table is actually on page 168. So once you type in your variables, you need to actually enter the values for the table. So go to page 168 to get the values for the table.
Oh, I'm not there. Josh.
I hit a brick.
Hey, no, like, it's confusing. Because they put restrictions on the iPad. And now all of a sudden, the Apple Store ain't. Like, oh, okay, so now we're looking at I can sign in the iPad. I can sign in the
Alright, so what's the temps that we have? 45?
25.
Wait, it was 45 to start though?
Yes.
45, 25, 60,
15.
and 100. And then customers,
97. 55. 85.
Alright, so to make a trend line the way y'all have been doing it, what do I need to create at this point? A graph, right? So how am I going to create that graph? What page do I need to create? So I'm going to go to menu. Whoops, not menu. Menu is not how I grab, how I create a new page. What do I need to press? Control and doc is where I need to go so that I can now create a graphs page for data and statistics. What page am I going to go to? Not number 2. Remember, 5 is when we're dealing with data and statistics. Huh? Time to learn some math? So, hit control and then doc. Guys, hit Control and then Doc, and then you need page 5, Data and Statistics. Addison, thank you for helping Thomas like that. Huh? So remember, along the x-axis, that's going to be my independent variable. Mary Lee, Thomas, eyes up here. What is the independent variable? The temperature. And what's the dependent variable? Customers. Now go through the process that we have already learned to put that least squares regression line in there. So you want data and statistics to do a graph with data and statistics. So yeah, you don't. So you want control dot.
It's supposed to be year person.
Add data and statistics. Now, oh, you just put it in here. So and customers. There you go. That's what you wanted. Now you're missing a data point, I think.
You cannot lie.
Oh, you never did enter that. Okay, y'all are different things. Did you get your least squares regression line in there? Did you follow my directions? No, dude. You clearly never hit and did a do document like I asked you to do. I didn't give you the data here. You need to pay attention when I am teaching things and telling you what to do. Come on. So what are you supposed to go to now? Barely, hold on. You notice you only have 4 data points on 5. You never hit enter. You have to hit enter after the last data point. Nice. Stay in your group. Stay in your group.
I only got 4 data points.
Alright, hey, pause, because I'm seeing the same pattern for some of us. I need y'all to go back and look at your table. If you still have your 100 right there looking like this and you haven't hit enter, you don't have a 5th data point yet. So what you need to do is hit enter. That creates the 5th data point. So when you come to here, hit that one again and re-put that variable in and it'll fix itself. Yes?
There we go.
Mechanical pencil in your hand.
There you need your dependent variable customers. Alright. Up there. Right hand side of that. Okay. So, what do I need to press to be able to get that least squares regression line? Menu. Then analyze. Then I need to not add movable line. Because listen, the add movable line was to learn about getting that minimizing the sum of squares. I want a regression. What regression do I want? I want to show a linear regression. I'm telling you this right here, right now. There will be the expectation that you be able to do this on your test. Or not on your test, but on the assessment, okay? There will be the expectation that you know how to create a linear regression like this on the assessment. Yes, sir? Did you go to regression? Number 6? There it is. You already have it there. So, yeah, by the way, I do want to point this out. Can I see this real quick? Some of you may see more decimals than what I have up there, but as long as they round to the same, you're good. Right? So if I look at Caitlin's, it goes 0.686577. That rounds to this number, so she'll be fine, okay? This is why you will need to write it down off of the calculator when you generate it. Yes, Thomas?
This, I had picked the wrong one, but I had went back and did it, and it gave me 2 lines.
So click on the line you don't want and then hit delete. Okay, I'll look at it in a second. Sir? Yes, Joey?
I don't know what I'm doing.
Okay, I'll show you in a second, bud. Okay, 2 quick things that I need y'all to pay attention to, and I want to show you is this. You do not have to go to this data and statistics page to get the equation of that line. Let's say I go back to the list and spreadsheets. Anybody have a guess where I could go in this list and spreadsheets, which you should go to this page now? Anaya, have you gone to this page? What you doing? Huh? So, anybody have a guess where I should go or what button I could press to be able to get the least squares regression line even from here?
Menu.
Okay, so if I go to menu, then what?
No
Okay, so
statistics.
there's no analyze, but there is statistics here.
Stat calculation.
Stat calculations. Oops, that's not what I wanted.
Then one there.
Menu, statistics, stat calc. We're not on one variable. Remember, I wanted a linear regression. Yeah, notice how there's a linear regression there. Now, please hear me. You don't have to do this. I'm just pointing out that you can. Sir, I'm talking. Why are you talking over me?
I'm sorry.
So the x variable, the independent variable is temperature. Customers is my dependent variable. And that's all I would need, I believe. And so I want you to note, do you get the same slope? Originally I had y hat equals 0.687 x plus 41 point. Why is there so much talking behind me while I'm teaching? Hold on. That was the equation that I originally got. Is that the same as what I see here for my slope?
Yes.
Just differently rounded. And this, is that what I see for the y-intercept? You don't have to worry about where to write it right now. I'm showing you how to get that least squares regression line. Okay? Alright, and Joey, I know that I need to come over and work with you on that, so just hold on, I'll do that. What are your questions about this before we continue? Do we know how to get the least squares regression line? Hold on, I'll come and check on it. What are your questions about getting the least squares regression line from the calculator? Okay. Did you have a question, Maddie? You good now? Okay. So, note, where does it say on the activity 1.1 where we're supposed to get the least squares regression line? Number what?
4.
Not 4. 5. Right here in the book, they call it a line of best fit. Anyone know another name for the line of best fit? Least squares regression line. The least squares regression line is the line of best fit. That's the more statistical term for it. So, you should write down your equation. And I want you to use your notes, take a couple of minutes, and talk about what they represent. So you should be able to look at that equation, identify the slope and y-intercept, and when the question here is what do they represent, what they're asking is for you to interpret them. Where have we gotten some practice with interpreting slope and y-intercepts? Number what? Is from the number 16. Number 16 in squared up. So go to number 16 in squared up to help you practice interpreting those values. Talk with those in your small group. Do you understand how we got this equation?